Revolving around an axis other than the x-axis is a little tricky. So here we have y is equal to 6 being revolved around y is equal to 1. So normally we'd call r of x 6, but since we're stopping short, the axis of revolution again being y is equal to 1, is really only 5 spaces away from y is equal to 1. So big R of x is going to be 6 minus 1, or just 5 when it revolves. Likewise, little r of x, which is f of x equals x squared plus 2, if it were going all the way down to the x-axis, it would be x squared plus 2. But we are stopping 1 short, so we need to take x squared plus 2, subtract 1. So little r of x is x squared plus 1. So it's a little tricky, but very doable. Now we take our formula. V is equal to pi big R of x squared dx minus pi little r of x squared dx. From the previous page, we saw that the big R of x was 5. Little r of x was x squared plus 1. They each stopped short because of the y is equal to 1 axis of revolution. So we have v is equal to pi from 0 to 2 pi squared dx minus pi 0 to 2 x squared plus 1 squared dx. And the rest of this is going to be algebra, 25 from 5 squared, x to the fourth plus 2x squared plus 1. Be careful to FOIL that. We have 25 minus, then combining the two integrals together, 25 minus the quantity of x to the fourth plus 2x squared plus 1. Make sure you distribute that negative. Simplify, you get 24 minus x to the fourth minus 2x squared. All the way up to there, all you've done is algebra. So we're not done with this problem. We now have to do the calculus. So 24 turns into 24x, minus x to the fourth turns into minus x to the fifth over 5, power rule. Minus 2x squared turns into minus 2x cubed over 3, power rule. Evaluate that from 0 to 2. Hopefully you're using your calculator for these kinds of computations. And your answer is 544 over 15 pi.